Yes, good evening, my dear students. So, in today's class, we will continue with the same D and F block chapter. So, in previous class, we are discussing regarding compounds of important transition elements. So regarding that, already we discussed about the potassium dichromate. So then next compound we have the very much important compound from this. So that is potassium permanganate. So how to prepare potassium permanganate and what is the commercial reaction? So that also we discussed in the previous class, and what are the properties and what are the structures of manganate and permanganate ions. So the next concept we have important reactions of acidified KMnO4. Okay, so what are the important reactions for the acidified KMnO4? We'll see one by one. So the next in acid solutions ಅಲ್ಲಿ ನಮಗೆ see here we have 10 iodine. Okay, iodine is liberated from potassium iodide. So iodine so Ki ಇರುತ್ತೆ. So Ki ಅಲ್ಲಿ K plus I minus ಏನಿರುತ್ತೆ. So ಈ I minus ನ if we consider, and here this KMnO4 will act as a oxidizing agent, and this will convert, or it will oxidize iodine to the iodine, it will convert iodine to the potassium iodide. Okay, so this is iodine, and here we'll get this is I minus is iodide to the iodine molecule we are going to get. Okay, so where in potassium permanganate MnO4 minus will act as a oxidizing agent. Then next we have Fe2 plus ion, which is in green color, is converted to Fe3 plus ions. Okay, so Fe2 plus ions are going to convert into what? Fe3 plus ions agi convert agutte. So where Fe2 plus are initially in green in color, and Fe2 plus ions are Fe3 plus ions are yellow in color. See ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ +2 ಇರೋದೇನಾಗ್ತಾ ಇದೆ, +3 ಆಗ್ತಾ ಇದೆ. Increase in oxidation number, we call it as oxidation ಅಂತ ಹೇಳ್ತೀವಿ. So that means where KMnO4 will act as a oxidizing agent. So then next we have oxalate ion or oxalic acid is oxidized at 333 Kelvin. Or oxalic acid is oxidized at 333 Kelvin. So here in oxalate ion C2O4 2 minus, oxalate ion or oxalic acid is oxidized at 333 Kelvin. So that means potassium permanganate is going to oxidize oxalate ion to the water and the carbon dioxide. Okay, so ಇಲ್ಲಿ 2Mn plus 2 plus 2 8 water and 10 moles of carbon dioxide is going to form. Okay, where here the potassium permanganate is acting as a oxidizing agent anta ನಾವು ಹೇಳ್ತೀವಿ. Okay, so that is about the acid solutions in acid medium. See, if you observe all these for 3 reactions, no, so in this reactions in all the reactions are taking place in the presence of acidic medium. Okay, so that here KMnO4 will act as a oxidizing agent to oxidize reactant molecule to the product. Next some more reactions we have. H2S is hydrogen sulfide. So hydrogen sulfide is oxidized, sulfur being precipitated. So hydrogen sulfide oxidize ಆದರೆ in the presence of potassium permanganate, ಸೊ ನಮಗೆ ಸಲ್ಫರ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗುತ್ತೆ. ನೋಡಿ ಇಲ್ಲಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ 2H plus plus S2 minus ಬರುತ್ತೆ. Then 5 moles of S2 minus plus 2 moles of MnO4 minus plus 16H plus is going to give 2 Mn2 plus 8 water plus 5 moles of sulfur we are getting as a precipitation. So that here potassium permanganate, so this will act as a oxidizing agent. Then next we have sulfurous acid or sulfite is oxidized to a sulfate or sulfuric acid. Okay, so ಒಂದು sulfurous acid ಅಥವಾ sulfite ಏನಾಗುತ್ತೆ which is going to oxidize to the sulfate or sulfuric acid. Sulfurous acid is oxidized to sulfuric acid and sulfite is oxidized to sulfate, we can say. See here we have 5 moles of SO3 2 minus when it is combined with the KMnO4. So in the acidic medium will be getting what? Sulfurous acid or sulfate ion anta ನಾವು ಹೇಳ್ಬೋದು. Then next reaction, nitrite ion is oxidized to nitrate. See ಇಲ್ಲಿ nitrite ion, nitrate ಇದೆ and nitrite ion. So the conversion of nitrite to nitrate ions. Okay. So NO3 minus is nitrate, NO2 minus is nitrite ion in the presence of acidic medium as well as in the oxidizing agent. In the presence of oxidizing agent, that is MnO4 minus, we are getting what? Mn2 plus and nitrite ion. Okay, so this is how the oxidation in the presence of oxidizing agent potassium permanganate, the reactions are going to happen in the presence of acidic solution or acidic medium. Next, in a neutral or faintly alkaline solutions, in neutral medium or faintly alkaline solutions medium ಅಲ್ಲಿ ಯಾವ ತರ ಆಕ್ಸಿಡೈಸ್ ಆಗುತ್ತೆ ಅಂತ. See the first reaction, oxidation of iodide to iodate. Okay, ನೋಡಿ iodide is a reactant molecule in the presence of this oxidizing agent in the presence of alkaline aqueous medium. So ನಮಗೆ ಪ್ರಾಡಕ್ಟ್ 2M1O2 plus 2OH minus and iO3 minus ಬರ್ತದೆ. This we call it as iodate. So iodate we are going to call this. Then next, thiosulfate is oxidized almost quantitatively to sulfate. See here we'll be having the oxidizing agent 8 moles. And thiosulfate, this is S2O3 2 minus is called as thiosulfate. It is going to oxidize to sulfate, SO4 2 minus agi oxidize agutte because of the presence of oxidizing agent. Then manganese salt is oxidized to MnO2. See ಇಲ್ಲಿ manganese salt, so that is Mn2 plus ಏನಿದೆ, this is going to oxidize in the presence of KMnO4. So the presence of zinc sulfate or ZNO catalyst, the oxidation is taking place. This reaction takes place in the presence of zinc oxide. So we will be getting Mn2 plus in the 5 moles of MnO2 ನಮಗೆ formation ಆಗುತ್ತೆ. Manganese salt ಏನಿರುತ್ತೆ that is going to oxidize to the MnO2. Okay. So that is in neutral ಅಥವಾ faintly alkaline solution medium ಅಲ್ಲಿ how the KMnO4 will act as a oxidizing agent and how the reactant molecules are converting into its respective ions or the molecules anta about this. Okay, then next we have, and also in the presence of water medium or the neutral medium. ನೆಕ್ಸ್ಟ್ ಯೂಸಸ್ ಆಫ್ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮಾಂಗನೇಟ್. ಸೊ ಈಗ ಈ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮಾಂಗನೇಟ್ನ ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ? ಸೊ ಮೇನ್ಲಿ ನೀವು ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಆರ್ ಯೂಸನ್ನ ನೆನ್ಪಿಟ್ಕೋಬಹುದು. ಹಾಗಂದ್ರೆ so you'll be having the practical in practical exam you are going to do one titration by taking potassium permanganate versus FAS. So ನೋಡಿ ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ it is used as a laboratory reagent in volumetric analysis. Okay, so volumetric analysis ಅಲ್ಲಿ KMnO4 is used as a what? Laboratory reagent ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. And also first point you see, it is used as a powerful oxidizing agent. So as of we discussed so many reactions, the conversion of iodine into the iodate irbodu, athwa so many reactions we discussed under acidic solution medium as well as the neutral medium alli. So all those examples shows where the potassium permanganate will be acting as a oxidizing agent anta. Okay, so that the main important or use of potassium permanganate is it is going to act as a powerful oxidizing agent, and also it is used as a laboratory reagent in volumetric analysis. And third use is it is used for bleaching wool, cotton, silk and other textile fibers. So bleaching method in case of wool irbodu athwa cotton irbodu, cotton industry, wool industry athwa silk industry and other textile fibers industries alli we are going to use potassium permanganate as a bleaching agent. Okay, bleaching agent, cleaning agent agi use ಮಾಡ್ತೀವಿ, bleaching agent. Next we have it is used for the decolorization of oils. So oils, while manufacturing oils, so if oils contain any color, so in order to remove that color of that oil, we are going to use a reagent potassium permanganate. Okay, so potassium permanganate will be used for the decolorization of oils anta ಹೇಳ್ತೀವಿ. So all these four uses are very very important. Maybe they asked for the 2 mark. Give any two uses of potassium permanganate or give any two uses of potassium dichromate ಕೇಳೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ for 2 mark. So then next we'll move on to the next concept. So the inner transition elements. So up to that one the transition elements. Next we have inner transition elements. So ಈಗ periodic table ಅಲ್ಲಿ S block elements are present on left side of the periodic table and P block elements are present on right side of the periodic table. Correct? So right side P block elements are present. Correct, no? So here we'll be getting how many groups and columns, groups or columns athwa periods athwa rows anta ಹೇಳ್ತೀವಿ. So we'll be getting 1 2 3 4 5 6 7 8 9 10 11 12 from 13 to 18. So we call it as P block elements anta ಹೇಳ್ತೀವಿ. 1 to 2 S block elements, 13 to 18 P block elements and from 3rd to 12 we call it as what? Now previous class allella ಏನು discuss ಮಾಡಿದ್ವಿ, that is transition elements are also called as D block elements anta ಹೇಳ್ತೀವಿ. Okay, so S block elements, P block elements and D block elements. And if you observe the periodic table, below the periodic table there is a presence of 2 rows. So 2 rows ಅಲ್ಲಿ elements na arrange ಮಾಡಿದ್ದಾರೆ. So for the first row we call it as lanthanum and second row we call it as actinium series anta ಹೇಳ್ತೀವಿ. So that elements we call it as inner transition elements. Inner transition elements anta ಹೇಳ್ತೀವಿ. So inner transition elements. Okay, so that this is about the arrangement of elements in the periodic table. So here let us know about inner transition elements ಏನಿದೆ and what are the properties and how is there any important compounds in F block elements. Everything we will discuss one by one. So next we have F block elements are also called as inner transition elements. Okay, so regarding this F block elements, we'll be having the first point is the elements in which the last electron enters the F orbitals of their atoms are called F block elements. See, usually periodic table alli elements na arrange ಮಾಡಿರೋದು based on the increasing order of their atomic number as per the modern periodic table. ಕರೆಕ್ಟಾ? ಸೊ ಈಗ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಏನು? ಇಫ್ ವಿ ರೈಟ್ ದ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಫ್ ದ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್, ಸೊ ದ ಲಾಸ್ಟ್ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಎಂಟರ್ಸ್ ಇನ್ ಟು ದ ಎಫ್ ಆರ್ಬಿಟಲ್ಸ್. ಸೊ ಲಾಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಫ್ ಆರ್ಬಿಟಲ್ಗೆ, ಔಟರ್ ಎಫ್ ಆರ್ಬಿಟಲ್ಸ್ಗೆ ಎಂಟರ್ ಆಗ್ತಿರೋದ್ರಿಂದ, ಸೊ ದಟ್ ಎಲಿಮೆಂಟ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕ್ಯಾಟಗರೈಸ್ಡ್ ಆರ್ ಕ್ಲಾಸಿಫೈಡ್ ಇನ್ ಒನ್ ಗ್ರೂಪ್. ಸೊ ದಟ್ ಗ್ರೂಪ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಆರ್ ನೇಮ್ಡ್ ಆಸ್ ವಾಟ್? ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ನಾವು ನೇಮ್ ಮಾಡ್ತೀವಿ. ದೆನ್ in these elements, the last electron is added to the F orbital of the anti-penultimate shell. ಸೊ ನಾವ್ ಏನ್ ಎಫ್ ಲಾಸ್ಟ್ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎಫ್ ಆರ್ಬಿಟಲ್ಗೆ ಆಡ್ ಮಾಡ್ತಿದೀವಿ, ಆ ಆರ್ಬಿಟಲ್ ನ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಆಂಟಿ ಪೆನಲ್ಟಿಮೇಟ್ ಶೆಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಆಂಟಿ penultimate shell. So that anti-penultimate shell is represented by n minus 2 into f. Okay, n minus 2 into f ಅಂತ represent ಮಾಡ್ತೀವಿ. Anti-penultimate shell which is represented as what? n minus 2 into f. Yes, so anti-penultimate shell we call it as the elements in which in these elements the last electron is added to the f orbital of the anti-penultimate shell, so that is n minus 2 f. Okay, so that means n minus 2 shell of the f orbital, the electron we are going to fill. Then these elements are also called inner transition elements. Okay, so because of the filling up of the electrons in n minus 2 f orbital, that is anti-penultimate shell, so that we are called as what? Inner transition elements. Then they consisting of two series of elements, namely lanthanides and actinides. So f orbital or f block elements are consisting of two series. So the first series we call it as lanthanide and second series we call it as actinides. So the lanthanides we call it as 4f series anta represent ಮಾಡ್ತೀವಿ. So see, starting from cerium, okay, lanthanum ಆದ್ಮೇಲೆ next elements ಎಲ್ಲ ಏನಿದೆ, starting from the atomic number 58 to 71, and 5f series, next series we call it as 5f series, and which are having the atomic number from 90 to 103. Okay, and the elements starting from thorium to lawrencium. So ella elements na together we call it as f block elements anta karitivi athwa inner transition elements anta ನಾವು ಹೇಳ್ತೀವಿ. Okay, so that is about the f block elements, a small introduction. Next we have lanthanides. So ನೋಡಿ ಈಗ starting from 57 to 71 ಯಾವ elements present ಇದೆ? The first 57 lanthanum we have, cerium we have, then praseodymium we have, then neodymium we have, promethium, then samarium, europium, gadolinium, then terbium, then dysprosium, holmium, erbium, thulium, ytterbium, then lutetium. Okay, all these elements we call it as lanthanides anta ಹೇಳ್ತೀವಿ. Then next we have, ನೋಡಿ ಇಲ್ಲಿ ನೀವು f orbital ಗೆ electrons enter ಆಗ್ತಿರೋದನ್ನ you can observe. See ಇಲ್ಲಿ 4f0 ಇದೆ, here we have 4f2, then 4f3, 4f4. See, the electrons, last valence electrons are enter into f orbital ಆಗಿರೋದ್ರಿಂದ we are considering all these elements in case under inner transition elements ಅಥವಾ we call it as F block elements. Okay, next we have actinides. See, starting from atomic number 89 to 103, we are together we call it as actinides or 5F series anta ಹೇಳ್ತೀವಿ. So lanthanides are 4F series and actinides are 5F series. So starting from actinium, thorium, protactium, uranium, neptunium, plutonium, americium, then curium, then berkelium, californium, einsteinium, fermium, mendelevium, nobelium, lawrencium. See, all these names are regarded the name by taking which from where it is extracted, or the based on their source, or which scientist was isolated or invented these elements, no, based on that the names are these elements are named as like based on their source or based on which scientist was invented. Okay, so that is about the actinides elements, also called as 5F series anta ಹೇಳ್ತೀವಿ. Next we have electronic configuration. What is the general electronic configuration for actinides andre? The general configuration is, see, n-2 F214 is anti-penultimate shell, then continue with the n-1 into d power 0 to 1 and ns2. Then inner 4f and 5f orbitals are progressively filled. So ಇಲ್ಲಿ 4f ಮತ್ತೆ 5f orbitals progressive ಆಗಿ fill ಆಗಿರುತ್ತೆ. ಓಕೆನಾ? So then next, the extra stability of off-filled orbitals is seen in the elements. So extra stability of off-filled orbitals is seen in the elements europium, which is having 4f7 6s2 configuration, and gadolinium, which is having the configuration 4f7 5d1 6s2. So it is because of the extra stability of off-filled orbitals ನಮಗೆ ಯಾವ್ಯಾವುದು ಆಕ್ಟಿನೈಡ್ಸ್ ಅಲ್ಲಿ ಅಂತ ಅಂದ್ರೆ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಯುರೋಪಿಯಂ ಮತ್ತೆ ಗ್ಯಾಡೋಲಿಯಂ, ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಕಾನ್ಫಿಗರೇಷನ್ ಲಾಸ್ಟ್ ವೆಲೆನ್ಸ್ ಶೆಲ್ ಕಾನ್ಫಿಗರೇಷನ್ 4s7 and 6s2. ಸಿ 4f7 ಇರೋದ್ರಿಂದ ಇಟ್ ಈಸ್ ಆಫ್ ಫಿಲ್ಡ್, ಅಂಡ್ ಇಯರ್ ಆಲ್ಸೋ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ 4s7 and 5d1. ಸೊ ಇಟ್ ಈಸ್ 4f7 ಇರೋದ್ರಿಂದ it is off filled. Okay, so then next we have next feature of the actinide, that is ytterbium. So which is having the configuration 4f14. ನೋಡಿ f orbital completely filled ಆಗಿರುತ್ತೆ. Okay, then lutetium ಅಲ್ಲಿ 4f14 completely filled ಆಗಿರುತ್ತೆ. So 4f7 ಇದ್ರೆ ಆಫ್ ಫಿಲ್ಡ್, 4f14 ಇದ್ರೆ we call it as completely filled ಅಂತ ಹೇಳ್ತೀವಿ. So this show the stability of the completely filled f orbitals. Okay, so these number of electrons are showing what the stability of the completely filled f orbitals. Then lanthanum, gadolinium, lutetium have single electron in 5d orbital. ನೋಡಿ ನಾವು ಇಲ್ಲಿ ಕಾನ್ಫಿಗರೇಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ d orbital ಅಲ್ಲಿ 1 electron ಇದೆ. In d orbital we have 1 electron, and here also we have 1 electron, correct? No, so these elements are ytterbium ಮತ್ತೆ lutetium is showing the stability of completely filled f orbitals. Then lanthanum, gadolinium. Okay, so see here in d orbital 1 electron, then lutetium will be having d orbital ಅಲ್ಲಿ 1 electron. Okay, have a single electron in 5d orbitals. Then the other lanthanides do not have electrons in 5d orbitals. So other than these elements, ರಿಮೈನಿಂಗ್ ಲ್ಯಾಂಥನೈಡ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನಿದೆ ಅದು 5d ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಯಾವುದೇ ರೀತಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಹೊಂದಿರೋದಿಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ದ ಅನದರ್ ಫೀಚರ್ ಆಫ್ lanthanides. Next, if we come to the oxidation states for the inner transition elements, the most common oxidation state and also the most stable oxidation state of the lanthanides is +3. So the most common and the most stable oxidation state of the lanthanides ಎಷ್ಟಿರುತ್ತೆ? +3 ಇರುತ್ತೆ. And in that cerium and terbium also exhibit +4 oxidation states. So cerium element ಮತ್ತೆ terbium element ಏನಿದೆ ಅದು ಕಾಮನ್ ಆಗಿ +4 oxidation state ಅನ್ನ ತೋರಿಸುತ್ತೆ. And an aqueous solution of cerium +4 is a good oxidizing agent. Cerium 4+ in aqueous medium, it is going to act as a good oxidizing agent ಆಗಿ act ಮಾಡುತ್ತೆ. So when cerium +4 is combined with Fe2+, it is going to give Ce3+ plus Fe3+ ಆಗಿ reduce ಆಗುತ್ತೆ. Okay, so that is so these are the points which you may get in 1 mark question as like or fill in the blanks also you will get the 1 mark questions type. Okay, next we have some of the elements exhibit +2 oxidation state as well. So ಕೆಲವೊಂದು ಎಲಿಮೆಂಟ್ಸ್ ಲ್ಯಾಂಥನೈಟ್ಸ್ ಅಲ್ಲಿ ಮತ್ತೆ ಲ್ಯಾಂಥನೈಟ್ಸ್ ಅಲ್ಲಿ +2 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ. ಅಂಡ್ aqueous solutions of Sm2 plus Eu2 plus and Yb2 plus are good reducing agents. ಸಿ ಇಲ್ಲಿ Sm2 ಪ್ಲಸ್ ವಾಟರ್ ಜೊತೆ ಕಂಬೈನ್ ಆದಾಗ Sm+3 ಫಾರ್ಮ್ ಆಗುತ್ತೆ, 2OH ಮೈನಸ್ ಪ್ಲಸ್ H2 ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ ದಟ್ next the actinides exhibit several oxidation states. So actinides the oxidation state bandaga it is going to exhibit the several oxidation states. Then +3 oxidation state is most common in actinides. So ade lanthanides alli bandaga what is the most common oxidation state? +3. And in actinides also the most common oxidation state is what? +3 ಆಗಿರುತ್ತೆ. Then actinides exhibit higher oxidation state from +4 to +7. See actinides ಹೈಯರ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟು ಯಾವ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ ಅಂದರೆ ಫ್ರಮ್ +4 to +7. ದೆನ್ ದಿಸ್ ಇಸ್ ಬಿಕಾಸ್ 5F 6D and 7S subshells have nearly equal energies. So ಯಾಕೆ most of the actinides or exhibits higher oxidation states from +4 to +7 ಅಂತ ಅಂದರೆ because of the 5F 6D and 7S subshells have nearly equal energy. ಸೊ ಈ 3 ಆರ್ಬಿಟಲ್ಸ್ ನಿಯರ್ಲಿ ಈಕ್ವಲ್ ಎನರ್ಜಿನ ಹೊಂದಿರೋದ್ರಿಂದ ಕಾಮನ್ ಆಗಿ ನಮಗೆ +4 ಇಂದ +7 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇರುವಂಥ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ನಾವು ಆಕ್ಟಿನೈಡ್ಸ್ ಅಲ್ಲಿ ನೋಡ್ಬೋದು. ಆಫ್ಟರ್ ದಿಸ್ ಸಿ ಈಗ ಇಲ್ಲಿ ಒಂದು ಲಿಸ್ಟ್ ಇದೆ ಲ್ಯಾಂಥನಮ್ ಸೀರೀಸ್ ಮತ್ತೆ ಆಕ್ಟಿನೈಡ್ ಸೀರೀಸ್ದು. ಸೊ ಲ್ಯಾಂಥನಮು ಸಿಂಬಲ್ ಏನು ಇರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಕಾಮನ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ನೋಡಿ ಇಲ್ಲಿ ಈ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಕಾಲಮ್ ಅಲ್ಲಿ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಲ್ಯಾಂಥನಮ್ +3, ಸೀರಿಯಂ +3, ದೆನ್ ಪ್ರೆಸಿಯೋಡಿನಿಯಂ +3, neodymium +3. So all the elements are commonly having one oxidation state that is +3. Okay, so that we are telling +3 is the most common oxidation state. Okay, so then configuration we are having here and also the in terms of +3 state what is the configuration. Yes, after that next we have actinides. So in actinides also if we starting from 89 to the 103 oxidation number whatever the elements are arranged in the periodic table, no, so all the elements together we call it as actinides anta heltivi. Next column we have symbols ide, then next we have oxidation states ide. So oxidation state alli bandaga the most common oxidation state +3 anta ಹೇಳಿದಿವಿ ನೋಡಿ, +3 up to here and here again we have +3. all the elements are having the common oxidation state +3. ಬಟ್ ಇಲ್ಲಿ +4 actinium +4 oxidation state ನ ತೋರಿಸಲ್ಲ. apart from actinium and californium, einsteinium, fermium, mendelevium, nobelium, lawrencium, all these are showing only the +2 and +3. Others are showing +4, +5, +6 and +7. ಸೊ +4 to +7 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇರುತ್ತೆ. ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅನ್ನ ತೋರಿಸುವಂತ ಆಕ್ಟಿನೈಡ್ಸ್ ಯಾವುದು ಅಂದ್ರೆ ನೆಪ್ಚೂನಿಯಂ ಮತ್ತೆ ಪ್ಲೂಟೋನಿಯಂ. ಓಕೆ, ನೆಪ್ಚೂನಿಯಂ ಮತ್ತೆ ಪ್ಲೂಟೋನಿಯಂ ವಿಲ್ ಶೋ ವಾಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ದೆನ್ electronic configuration we have as per the actinides. Okay, next we'll move on to the next topic, ಕಲರ್ ಆಫ್ ದ ಲ್ಯಾಂಥನೈಡ್ಸ್. ಸೊ ಈಗ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಕಲರಿಂಗ್ ಪ್ರಾಪರ್ಟಿ ಯಾವ ತರ ಇರುತ್ತೆ? ಮೆನಿ ಟ್ರೈವೇಲೆಂಟ್ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಅಂದ್ರೆ ಲ್ಯಾಂಥನಮ್ +3. ಓಕೆ, ಸೊ +3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇರುವಂತ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಆರ್ ಕಲರ್ಡ್ both in solid state and in the aqueous solution state. So the elements which are in a +3 oxidation state, those elements are we call it as what they are colored in nature. Okay, so they are colored in both solid state as well as in aqueous solution we can say. Next we have color of these ions is due to the presence of F electrons. So why the lanthanides are showing the color means because of the presence of F electrons. So F orbitals ಅಲ್ಲಿ anti penultimate shell ಅಲ್ಲಿ electrons present ಇರೋದ್ರಿಂದ so lanthanides are showing the color. Then neither lanthanum plus 3 or lutetium plus 3 ion shows any color. So ಒಂದು lanthanum plus 3 ಅಥವಾ lutetium plus 3 ions ಏನಿರುತ್ತೆ ಅದು ಯಾವ್ದಾದ್ರೂ ಕಲರ್ ಅನ್ನ ಅಪಿಯರ್ ಮಾಡುತ್ತೆ or exhibit ಮಾಡುತ್ತೆ. Next, what are the magnetic properties of lanthanides? So ಹಾಗಿದ್ರೆ magnetic properties of lanthanides ಏನಿರುತ್ತೆ? The lanthanide ions other than F type, that is lanthanum plus 3 ಮತ್ತೆ cerium plus 4 and the type F14, so F0 type ಅಥವಾ F14 type ಏನಿದೆ, so yttrium yttrium 2 plus and lutetium plus 3 are all paramagnetic ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. So the lanthanides which are of the type F0 type ಅಥವಾ F14 type completely filled ಅಥವಾ not there is no presence of electrons in that F orbital, so that are going to behave as a paramagnetic ಅಂತ ಹೇಳ್ತಾರೆ. Okay, so then paramagnetism is raises to the maximum in neodymium ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. So maximum paramagnetic property ಯಾವ lanthanide ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ neodymium ಅಲ್ಲಿ ನಮಗೆ maximum paramagnetic or strong magnetic field ಇರೋದನ್ನ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು neodymium. Next we have physical properties. So what are the physical properties of the lanthanides and actinides ಅಂತ ಅಂದ್ರೆ they are high density. So lanthanides and actinides are having high density and high melting points. So lanthanides ಗೆ ಮತ್ತೆ actinides ಗೆ ಜಾಸ್ತಿ ಡೆನ್ಸಿಟಿ ಇರುತ್ತೆ and they're having the high melting points. Then a well known alloy of lanthanides and actinides is mish metal. So well known of alloy of lanthanide. So lanthanide ಮತ್ತೆ actinides ನ mix ಮಾಡಿದಾಗ like when we combine one lanthanide on one actinide, so alloy is nothing but what a mixing up of two or more metals is called as alloy. So ಆ ತರದ್ರಲ್ಲಿ lanthanide so will be getting one alloy, so that is a well known metal, we call it as what mish metal ಅಂತ ಹೇಳ್ತೀವಿ. So this is very very important, maybe you will get this mish metal for 2 mark ಗೆ ಕೇಳ್ತಾರೆ. It consists of a rare earth metal. So mish metal rare earth metal 94 to 95% ಇರುತ್ತೆ. rare earth metal you will be having 94 in mish metal ಅಲ್ಲಿ. rare earth metal is 94 to 95%, iron up to 5%. Okay, and traces of sulfur, carbon and calcium and aluminum present irutte. Okay, so 94 to 95% of what rare earth metal irutte, iron 5%, and also traces of sulfur, carbon, calcium ಮತ್ತೆ aluminum combination ಅಲ್ಲಿ ಇದ್ರೆ ಅದನ್ನ ನಾವು mish metal ಅಂತ ಹೇಳ್ತೀವಿ. Next we have, it is pyrophoric. It is pyrophoric. Pyrophoric means ignites spontaneously in air. So that means when we subject that lanthanides or actinides to the flame or ignite it to the flame, and when we ignite that elements to the flame in the presence of air, it is pyrophoric means and ignites spontaneously in air anta heltivi. So that means it will give some fire. So example it is used in a cigarettes, gas lighters, tracer bullets, shells, etc. Okay, so ಈ actinides ಮತ್ತೆ lanthanides metals ಏನಿದೆ or elements, so ಇದು like airಗೆ in the presence of air ನಾವು ಅದನ್ನ crush ಮಾಡಿದಾಗ it will catch some fire. So fire ನ catch ಮಾಡುತ್ತೆ immediate ಆಗಿ, so that we call it as pyrophoric ಅಂತ ಹೇಳ್ತೀವಿ. Then 3% mish metal is that is pyrophoric means mish metal is pyrophoric and it is used in a cigarettes ಅಲ್ಲಿ ಮತ್ತೆ gas lighters, tracer bullets and shells ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Then 3% mish metal is added to magnesium for making jet engine parts with an increased strength. ಸೊ 3% ಆಫ್ ಮಿಶ್ ಮೆಟಲ್ ನಮಗೆ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ವಿತ್ ಮೆಗ್ನೀಷಿಯಂ ಜೊತೆ ಆಡ್ ಮಾಡಿಬಿಟ್ಟು ಜೆಟ್ ಎಂಜಿನ್ ಪಾರ್ಟ್ ಪ್ರಿಪರೇಷನ್ ಅಲ್ಲಿ ಇನ್ ಆರ್ಡರ್ ಟು ಇನ್ಕ್ರೀಸ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದಟ್ ಇಂಜಿನ್. So they are going to use the mish metal. So about 3% of the mish metal they are going to use by adding magnesium metal. So that is about the some physical properties. So next we have chemical properties. So this is lanthanum. So here this is a like star mark like flow chart to by taking this one chart we can complete all the reactions or chemical reactions of the lanthanides. See ಈಗ lanthanides first one with acids. ಸೊ ಲೈಕ್ HCl ಇರ್ಬೋದು, HNO3 ಇರ್ಬೋದು, ಆರ್ H2SO4 ಇರ್ಬೋದು. ಲ್ಯಾಂಥನೈಡು ಆಸಿಡ್ಸ್ ಜೊತೆ ಕಂಬೈನ್ ಆದಾಗ ವಿಚ್ ಗ್ಯಾಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರೊಡ್ಯೂಸ್, ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ನಮಗೆ ಲಿಬರೇಟ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ರಿಯಾಕ್ಷನ್ ವಿತ್ ಹ್ಯಾಲೋಜನ್ಸ್. ಲ್ಯಾಂಥನಮ್ ಹ್ಯಾಲೋಜನ್ಸ್ ಜೊತೆ ಕಂಬೈನ್ ಆದಾಗ ನಮ್ಗೆ ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಲ್ಯಾಂಥನಮ್ ಹ್ಯಾಲೈಡ್, ಟ್ರೈ ಹ್ಯಾಲೈಡ್ಸ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ. ಓಕೆ, lanthanum trihalides are going to form. Next, if we come to the third reaction, what happens when lanthanum is treated with water? Lanthanum trihydroxide. Okay, lanthanum trihydroxide along with the hydrogen gas is going to liberate. Lanthanum trihydroxide along with the hydrogen gas is going to liberate. Then fourth reaction, when lanthanum is treated with a coke. Okay, so coke in the presence of 2773 Kelvin temperature, lanthanum carbide is going to form. Lanthanum carbide is going to form as a product, carbide. Okay, then next fifth reaction we have, what happens when lanthanum is treated with a nitrogen? Lanthanum nitrides are going to form. Lanthanum nitrides are going to form. Then what happens when lanthanum is treated with a sulfur anta andre? So we'll be getting lanthanum sulfides. Okay, so respective sulfides are going to form. Then what happens when lanthanum is treated with oxygen, that is O2? Lanthanum trioxides are going to form. Okay, ಈ ರೀತಿ ನಮಗೆ ಲ್ಯಾಂಥನಮ್ಮು ಯಾವೆಲ್ಲ ಅಟ್ಮಾಸ್ಫಿರಿಕ್ ಕಂಡೀಷನ್ಸ್ ಜೊತೆ ರಿಯಾಕ್ಷನ್ ಆದಾಗ ವಾಟ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫಾರ್ಮ್ ಅಂತ ಅಂದರೆ, ಸೊ ರೆಸ್ಪೆಕ್ಟಿವ್ ಸಲ್ಫೈಡ್ಸು, ರೆಸ್ಪೆಕ್ಟಿವ್ ನೈಟ್ರೈಡ್ಸು, ರೆಸ್ಪೆಕ್ಟಿವ್ ಕಾರ್ಬೈಡ್ಸು, ರೆಸ್ಪೆಕ್ಟಿವ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ಸು, ರೆಸ್ಪೆಕ್ಟಿವ್ ಹ್ಯಾಲೈಡ್ಸು, ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಕ್ಸೈಡ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫಾರ್ಮ್ ಆಸ್ ಎ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಸೊ ಆಲ್ ದೀಸ್ ಆರ್ ದ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್. Next we have lanthanide contraction. See, this part is very important for the exam. You may get this question for the 3 mark, that is define lanthanide contraction and what are the consequences under lanthanide contraction. They'll ask this question for the 3 mark. So in lanthanide series with the increase in atomic number, so as lanthanide series alli in atomic number 71 ಇಂದ increase ಆಗುತ್ತೆ. Sorry, not 71. So whatever the lanthanides are there, no, see from 57 in the 51 to 71. So from 71 actinium will start. So 57 lanthanum, cerium, praseodymium, ಮತ್ತೆ neodymium, then promethium, then etc. whatever the lanthanide elements are present, no, so that with the increase in the atomic number there is a regular decrease in the size of the atoms. ನೋಡಿ ಇಲ್ಲಿ 57 ಇಂದ 58 to 59 ಆ ಥರ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತಲ್ವಾ. ಈಗ 57 ಅಟಾಮಿಕ್ ಸೈಜ್ ಈ ಥರ ಇದ್ರೆ 58 ಇನ್ನೂ ಕಡಿಮೆ ಆಗುತ್ತೆ, 59 ಇನ್ನೂ ಕಡಿಮೆ, 60 ಇನ್ನೂ ಕಡಿಮೆ, and 61, 62, 63 like that. So when increase of atomic number, the size of the atoms are going to decrease regularly. Okay, and ions form lanthanum to lutetium. So from lanthanum to lutetium ಏನಾಯ್ತು, as the increase of atomic number, atomic size of the atom is going to, ionic size of the atom is going to decreases. The contraction of atomic and ionic size along the period of lanthanide elements from lanthanum to lutetium is called as lanthanide contraction. The gradual decrease in atomic size or ionic size of the lanthanides starting from lanthanum to lutetium is called as lanthanide contraction anta heltivi. Okay, so that is about the lanthanide. So it's very easy answer. So the gradual decrease of gradual decrease of atomic size or ionic size with increase in atomic number, okay, is called as lanthanide contraction. ನೆಕ್ಸ್ಟ್ ಕಾಸ್ ಫಾರ್ ದ ಲ್ಯಾಂಥನೈಡ್ ಕಾಂಟ್ರಾಕ್ಷನ್. ಈಗ ಲ್ಯಾಂಥನೈಡ್ ಈ ಕಾಂಟ್ರಾಕ್ಷನ್ ಯಾಕೆ ಆಗ್ತಿದೆ ಅಂತ ಅಂದ್ರೆ, ದ ಫಸ್ಟ್ ರೀಸನ್ ಈಸ್ ಅಲಾಂಗ್ ದ ಲ್ಯಾಂಥನೈಡ್ ಸೀರೀಸ್ ದ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಇನ್ಕ್ರೀಸಸ್ ಬೈ 1 ಯೂನಿಟ್ ಅಟ್ ಈಚ್ ಸಕ್ಸೆಸಿವ್ ಎಲಿಮೆಂಟ್. ಸೊ ಫ್ರಮ್ 57 ಇಂದ ಏನ್ ಎಲಿಮೆಂಟ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ಸೊ ಆ ಸ್ಟಾರ್ಟಿಂಗ್ ಫ್ರಮ್ 57 to 71 ಎಲಿಮೆಂಟ್ಸ್ ಇದೆಯಲ್ವಾ, ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಅಟಾಮಿಕ್ ಸೈಜ್ ಅಥವಾ ಅಯಾನಿಕ್ ಸೈಜ್ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅಟಾಮಿಕ್ ಸೈಜ್ ಅಥವಾ ಅಯಾನಿಕ್ ಸೈಜ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಡಿಕ್ರೀಸ್, ಬಟ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ಅಲಾಂಗ್ ವಿತ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ is going to increase. ಸೊ ಯಾಕೆ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ಆಫ್ ದ ಇನ್ಕ್ರೀಸ್ ಆಫ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ, ಆಡ್ ಆಗ್ತಾ ಬರ್ತಾ ಇರುತ್ತೆ ಫಾರ್ ದ ಎಫ್ ಆರ್ಬಿಟಲ್. So by 1 unit the nuclear charge is going to increase us by the 1 unit in between the two successive elements. Then the new electron is added to the 4f orbitals. That's what we discussed in first point. So new electrons f orbital ge add on ಆಗ್ತಾ ಬರ್ತಾ ಇರುತ್ತೆ. Then the shape of the f orbital is much diffused. So f orbital shape ಏನಾಗುತ್ತೆ, diffuse ಆಗ್ತಾ ಬರುತ್ತೆ ಆಗ. So the electrons in them cannot effectively shield the nuclear charge from the valence electrons. So whatever the electrons are present in the f orbitals, no, ಆ electrons na we cannot it cannot effectively shield the nuclear charge from the valence electrons. Then this ineffective shielding is unable to counterbalance the effect of increased nuclear charge. So because of the presence of ineffective shielding effect, so it is unable to counterbalance the effect of increased nuclear charge. So hence the net result is contraction in size, though the decrease is a very small. Even though gradual ಆಗಿ ನಮಗೆ ಅಟಾಮಿಕ್ ಸೈಜ್ or sudden decrease ಆದಾಗ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಅಲ್ಲಿ, ಸೊ ನಮಗೆ ನೆಟ್ ರಿಸಲ್ಟ್ is contraction in size, though the decrease is very small. Okay, so very small variations ಅಲ್ಲಿ ನಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಅಯಾನಿಕ್ ಸೈಜು ಅಟಾಮಿಕ್ ಸೈಜ್ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ. Next we have consequences of the lanthanide contraction. See, consequences very important for the exam. So you may get the question like 2 plus 1. One is define lanthanide contraction and 2 marks is for the consequences. Or separate agi nimge what are the consequences for lanthanide contraction anta kelo chances irutte. So it is difficulty in the separation of lanthanides. So lanthanides na separate ಮಾಡೋದು ತುಂಬಾ ಡಿಫಿಕಲ್ಟ್ ಆಗಿರುತ್ತೆ. Similarity in size of elements belonging to the second and third transition series. So ಈಗ 4f series starting from 57 to 71 ಅಲ್ವಾ. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ, similarities of in size of the elements belonging to the second and third transition series. Similarities ಇರೋದ್ರಿಂದ ನಮ್ಗೇನಾಗುತ್ತೆ, ಕಾನ್ಸಿಕ್ವೆನ್ಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ, ಲ್ಯಾಂಥನೈಡ್ ಕಾಂಟ್ರಾಕ್ಷನ್ಸ್ ಆಗುತ್ತೆ. ದೆನ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಜಿರ್ಕೋನಿಯಮ್ 160 ಪಿಕೋಮೀಟರ್ ಇದ್ರೆ ಆಫ್ಮಿನಿಯಮ್ 159 ಪಿಕೋಮೀಟರ್ have almost all the same size. ನೋಡಿ 159 160 it is almost all the same size ಆಗುತ್ತೆ. Due to this zirconium and osmium have almost same chemical properties and hence their separation is very difficult ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. ಸೊ ದೀಸ್ ಆರ್ ದ ಫ್ಯೂ ಇವನ್ ದೋ ನಮಗೆ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗ್ತಿದ್ರು ಸಹ ಕಾನ್ಸಿಕ್ವೆನ್ಸಸ್ ಏನೇನು ನಾವು ಫೇಸ್ ಮಾಡ್ತೀವಿ ಅಂತ ಅಂದ್ರೆ, ಸೊ ಇಟ್ ಈಸ್ ಡಿಫಿಕಲ್ಟ್ ಟು ಸಪರೇಟ್ ದ ಲ್ಯಾಂಥನೈಡ್ಸ್ and similarity in size of elements belonging to the second and third transition series ಆಗಿರುತ್ತೆ. ಎಕ್ಸಾಂಪಲ್ಸ್ ನಾವು ಜಿರ್ಕೋನಿಯಂ ಅಂಡ್ ಆಫ್ನಿಯಂ ತಗೊಂಡಾಗ ಸೊ ಬೋತ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ಆಲ್ಮೋಸ್ಟ್ ಆಲ್ ಸೇಮ್ ಸೈಜ್ and due to this zirconium and osmium have almost same chemical properties and hence their separation ತುಂಬಾ difficult ಆಗುತ್ತೆ. These are the consequences. Next we have actinide contraction. So there is a gradual decrease in the size of the atom or M3 plus ion across the actinide series. So actinide contraction andrunu ಏನಾಗುತ್ತೆ atomic size ಅಥವಾ ionic size starting from 71 atomic number to 103 ಏನಾಗುತ್ತೆ. So because of increase in atomic number. So atomic number increase ಆಗುತ್ತೆ but atomic size ಅಥವಾ ionic size ಏನಾಗುತ್ತೆ decrease ಆಗ್ತಾ ಬರುತ್ತೆ. Gradually the size of the atom is going to decrease. This is called as actinide contraction anta heltevi. So this is also very important for the 1 mark. So then this results from the poor shielding by the 5f electrons. So yaake actinides contraction agutte andre so because of the poor shielding by the FIF electrons, poor shielding effect inda namge actinide contraction occur agutte. Next we have general characteristics of lanthanides. Lanthanides general characteristics ಏನಿರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ ನೋಡಿ, all the lanthanides are silvery white sock metals and tarnish rapidly in air. So ಎಲ್ಲ lanthanides ಸಿಲ್ವರಿ ಕಲರ್ ಇರುತ್ತೆ, ವೈಟ್ ಸೋಕ್ ಮೆಟಲ್ಸ್ ಆಗಿರುತ್ತೆ ಅಂಡ್ ಟಾರ್ನಿಶ್ ರಾಪಿಡ್ಲಿ ಇನ್ ಏರ್ ಜೊತೆ ಕಂಬೈನ್ ಆದಾಗ ಇಮಿಡಿಯೇಟ್ಲಿ ದಟ್ ಸಿಲ್ವರಿ ಕಲರ್ ಆರ್ ವೈಟ್ ಸೋಕ್ ಕಲರ್ ಏನಿರುತ್ತೆ ಅದು ಶೇಡ್ ಆಗ್ತಾ ಬರುತ್ತೆ when they are treated with the air. Then the hardness increases with increase in atomic number. So from 57 to 71 ಏನಿದೆ ಈಗ 57 ಇರುವಂತ element will be having less hardness than that of the element which is having the atomic number 58 ಆ ತರ. So as the atomic number increases, hardness also increases. Then they are good conductors of heat and electricity. So lanthanides ಮುಖಾಂತರ ನಾವು electricity ನ ಪಾಸ್ ಮಾಡಬಹುದು ಮತ್ತೆ heat ನ ಪಾಸ್ ಮಾಡಬಹುದು. Then many trivalent lanthanide ions are colored both in solid state as well as in the aqueous solution state. So this is also one characteristic. Then color of these ions may be due to the presence of electrons. So ಯಾಕೆ lanthanides are showing the coloring property ಅಂತ ಅಂದ್ರೆ because of the presence of the unpaired electrons. Then the lanthanide ions other than F0 type ಮತ್ತೆ F14 type all are paramagnetic ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so F0 type elements ಅಥವಾ F14 completely filled elements ಅಥವಾ not filled elements. So F orbital ಅಲ್ಲಿ ಯಾವುದೇ ರೀತಿ electrons fill ಮಾಡದೇ ಇರುವಂತ elements ಅನ್ನ we are not considering as a paramagnetic because there is no unpaired electrons in that. Next we have applications of D block elements. So D block elements applications ಏನೇನಿದೆ ಅಂತ ಅಂದ್ರೆ iron and steels are the most important construction materials. So obviously ನಾವು construction ಅಂತ ಬಂದಾಗ compulsory iron and steels very they'll play very important role in a construction industry like construction materials. Then titanium oxide is used as a pigment industry. Titanium oxide na pigment agi use ಮಾಡ್ತಾರೆ in pigment industry. Then MnO2 manganese dioxide is used in a dry cells. So dry cells ಅಲ್ಲಿ MnO2 ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. zinc nickel ಇರಬಹುದು cadmium are used in a battery industries. zinc nickel ಮತ್ತೆ cadmium metals ನ battery industries ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Then the elements of group 2 are used as a coinage metals. So coinage metals ಅಲ್ಲಿ ನಮಗೆ group 2 elements ನ combine ಮಾಡಿಬಿಟ್ಟು as alloy ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Then many of the D block elements are used as a catalyst. So most of the D block elements are used as what catalyst ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾ ಬರ್ತೀವಿ. Next we have applications of F block elements. So what are the applications of lanthanides ಮತ್ತೆ actinides uses ಏನಿದೆ ಅಥವಾ applications ಏನಿದೆ ಅಂತ ಅಂದ್ರೆ the first one is lanthanide oxidizers are used for a polishing glass. So glass polishing process ಅಲ್ಲಿ lanthanides ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Then cerium salts are used in a dyeing cotton. Cerium salts are used in a dyeing cotton. ಅಂದ್ರೆ ಫಾರ್ ಕಾಟನ್ ಕಲರಿಂಗ್ ಪರ್ಪಸ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾರೆ cerium salts ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ದೇ ಆರ್ ಆಲ್ಸೋ ಯೂಸ್ಡ್ ಆಸ್ ಅ ಕೆಟಲಿಸ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ದೆನ್ ಲ್ಯಾಂಥನೈಡ್ ಕಾಂಪೌಂಡ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಆಸ್ ಅ ಕೆಟಲಿಸ್ಟ್ ಫಾರ್ ಹೈಡ್ರೋಜನ್. Usually hydrogenation is taking place in the presence of nickel catalyst or palladium catalyst presence alla agutte, oxidation process and petroleum cracking etc. So in all these process the lanthanides are going to use. Then mish metal is used as in magnesium based alloy to produce bullets and shells, and also in a jet engines ಅಲ್ಲಿ ಸಹ ಮಿಶ್ ಮೆಟಲ್ ಅನ್ನ 3% ಮಿಶ್ ಮೆಟಲ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Then mixed oxides of lanthanides are employed as a catalyst in petroleum cracking. Petroleum cracking process ಅಲ್ಲಿ mixed oxides of lanthanides ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ as a catalyst ಆಗಿ. Then some individual lanthanide oxides are used as a phosphorus in television screens and similar fluorescing surfaces ಅಲ್ಲಿ some individual lanthanide oxides ಅನ್ನ ಏನ್ ಮಾಡ್ತಾರೆ as a ಫ್ಲೂರಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಬರ್ತಾರೆ ಲ್ಯಾಂಥನೈಡ್ಸ್ ಅನ್ನ. ಸೊ ದೀಸ್ ಆರ್ ದ ಫ್ಯೂ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಯೂಸಸ್ ಆಫ್ ಲ್ಯಾಂಥನೈಡ್ಸ್ ವಿ ಕ್ಯಾನ್ ಸೇ. Next we have uses of actinides. So you may get for these uses 2 marks ಗೆ ಕೇಳೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ, uses of lanthanides ಮತ್ತೆ actinides. So if we come to the uses of actinides, thorium oxide is used for making incandescent mantles. Okay, so in the preparation of mantles thorium oxide is used for making incandescent mantles anta helteve. Then thorium salts are used in medicines in the treatment of cancer. So cancer treatment alli thorium salts na use ಮಾಡ್ತಾರೆ. Then uranium is used in the production of nuclear energy by the process of nuclear fission. So nuclear fission process alli uranium na use ಮಾಡ್ತಾರೆ for the production of nuclear energy. Then uranium salts are used in textile industry, ceramic industry as well as medicines formally uranium ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. And plutonium is used as a fuel in atomic reactors. So atomic reactors ಅಲ್ಲಿ plutonium ಅನ್ನ as a fuel ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾ ಬರ್ತಾರೆ. So all these are the uses of actinides we can say. Okay na. So then that is about D and F block element chapter. So with this we completed the theory part of the D and F block elements. See ಈಗ ನಿಮಗೆ ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಅಂತ ಅಂದ್ರೆ ಸೊ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ KMNO4 ಮತ್ತೆ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ಪೊಟ್ಯಾಷಿಯಂ ಡೈಕ್ರೋಮೇಟ್ ಅಂಡ್ ಪ್ರಾಪರ್ಟೀಸ್ ಏನೆಲ್ಲ ಇದೆ ಆ ಪ್ರಾಪರ್ಟೀಸ್ ನ 3 ಮಾರ್ಕ್ಸ್ಗೆ ಕೇಳೋ ಚಾನ್ಸಸ್ ನಿಮ್ಗೆ ಇರುತ್ತೆ. ಓಕೆ, ದೆನ್ actinide and lanthanide contraction ಮತ್ತೆ ಅದರ ಕಾನ್ಸಿಕ್ವೆನ್ಸಸ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಯು ಡೋಂಟ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ದಟ್ ಮಚ್. ಸೊ ಯು ಗೋ ಫಾರ್ ದ ಕಾನ್ಸಿಕ್ವೆನ್ಸಸ್ ಆಫ್ lanthanide ಮತ್ತೆ actinides ಬಗ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ನೀವು ಥಿಂಕ್ ಲೈಕ್ ಇಫ್ ಯು ಗೋ ಥ್ರೂ ಇನ್ ಟು ದಟ್ ಟಾಪಿಕ್ಸ್ ನೋ, ಸೊ ದೋಸ್ ಆರ್ ದ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ಸ್. Okay, so with this I will stop this the theory topic for the board exam. So in next class I will continue with the competitive questions from this chapter.